Hey everyone, good morning.
Good morning.
Hey everyone, good morning. How did the weekend go? It's a long weekend. All you guys had holiday on Friday, right? You guys were working, or how many of you had holidays on Friday? Okay. Let's wait for a few more minutes for others to join. Let me know if you have any questions while we wait. I think we'll get started. Is my screen visible to everyone?
Yes, sir.
Start the YouTube. So I think last week in Kubernetes, we were trying to understand how does a container gets created. So basically for that, we understood that containers will be running inside one more layer called a pod, right? Then on top of it, we saw that what are the different, behavior of pod, because by default, when you say a pod, it's singular in nature, and what it does is it will just create the container and it doesn't have any ability to scale or replicate. So that's where you will be creating a replication object, and then you will be creating a deployment object so that the pod gets the ability to replicate, scale, as well as you will also get the ability to roll back or undo the changes, which is where we saw pod object, then replica set object, and deployment object. Now to continue, let's understand some of the basics of how the networking happens within the cluster. Okay, so how does the basic communication happens? So let's say when you have a container, now I told you that in a pod by default there will be only one container. However, within a pod sometimes might also have more than one container. Okay. Suppose if you want to do a communication between one container and another container within the same pod, then you should be usually using a local host. Okay, so remember that. So within the pod, you can have more than one container, but when they have to communicate between each other, you can simply say local host. That means assume that on container one, you are running some application that you can easily go back to second container and then you can just access it. Okay, so that way it feels as if all the containers are running in the same place. So that way, anything within the pod, if you want to access or communicate between the two containers, you will be just using localhost. Now to show you what I'll do, I'll try to take a new pod. Okay, and this pod, what I'll do, I'll try to take two containers. You see here, so I have a pod. In this, I have one container in which I'm just trying to print my name in a loop. However, on the second container, you have Apache running and I'm exposing the port 80. So by default, when you expose a port from the container, it will be available within the pod only. So now, if I go to my first container and if I say localhost 80, you should be able to access the port 80 coming from the second container. Okay, so let's try this. We go back to issue. Okay. Okay. Let's say VI font 7, normal. Right. So you should see this time you have two containers, and once both of them are available, now let's go to first container. Okay, so how do I go to first container? You will say kube30 exe and that's the font name, and I want to go to the first container, so I'll say z00. This time I want to go inside interactively, so I'll just say 190. Okay, so we are going directly inside the first container. Now here you can access your second container, because if you look at this, C00 has a loop running and C01 has the second one. So this is where, now in order for us to access the first container, I can use curl, but just make sure sometime if curl is available or not. In case if it's not there, let's go ahead and do an apt update. Curl. Okay, so now from here, if I say curl open host 80, you can see the port 80 exposed from the second container is accessible from the container 1, that is C0. So this is where communication within a pod happens using localhost. Okay. Now we'll see the next one. How does it happen outside? But go ahead and try this. Let me just put this in the notes. Inside and just say post. You should be able to get this on the second container. Okay. So whatever the port running on the second container will be exposed within the pod, and that you can access from the first container using localhost. Let me edit this notes file. Just try running this and see how you can communicate.
Adam,
Yeah.
in GitLab, there is no pod YAML file.
No, this is the notes. If you go to this file notes.txt, I'm just copy pasting all the content. You can clone that and copy from this.
Okay.
Yeah. Check for notes.txt inside the folder called Jenkins file.
No, Adam, that is pod 7.yaml file. Only you put the commands.
It's not there.
Yeah.
Copy paste. Yes, what about others? Have you tried this or not? I mean, if I haven't pasted this, I'm not sure what you guys are doing. Okay. Let me- Can you check if it's now available?
Yes, it's now available. Thanks.
Yeah, thank you. with others? Have you tried? Others, have you tried? Others? So now what I was showing you is, if you have two containers within the same pod, how are you going to communicate? But what happens is, let's say you don't want to communicate between two containers in the same pod. And going back to the basics, you will have a container in one pod. Suppose if you want to communicate between one container in a pod to another container in a different pod, then we need to understand within the cluster. So when I say within the cluster, if you go to any machine which is in your Kubernetes cluster, if you want to access a container in a pod from another container, that is one pod to another pod, then you should be using the pod IP, which is going to be unique. Okay, so that way, any pod that you want to access inside a container which has some port being exposed from the container, you will be able to access it using the unique IP of the pod. Okay. Now, to understand the next example, what we'll do, I'll take this. Okay. So here, what I'll do, so we'll create a new pod. All right. And for this pod, I will run Nginx. All right. This is the first thing I'll do. Pod h.yaml. So kubectl. Okay, so this is running. So what I'll do in the same example, I'll just copy pod 8 to pod 9.yaml. So here what I'll do, I'll just rename all these things. I'll just change pod 9. Instead of Nginx, let's run Apache image. So on pod 8, you will be having Nginx, and pod 9, you will be having Apache running. So you have two pods, 8 and 9. Now 8 will be having Apache and 9 will be having, 8 will be having Nginx, 9 will be having Apache. If you do a kubectl get pods -y, so you'll be able to see that each pod has its unique IP. Okay, and now if any container is exposing a port, you can directly access it using this unique ID. So now when I say curl pod 8, you can see this is accessing Nginx, which is available on pod 8. The same way, if you say curl and the pod 9's IP and say 80, you should see this is accessing Apache. So this is how every pod is going to be unique. And if you want to access a container in a pod from another pod or a container, if you use the unique IP of the pod, you will be able to access it. Okay. So just try this and see how it works. So one is create a pod, then create pod 9. This just change the name. Let me try creating two containers and go ahead and do a curl from the IP, and you should be able to see specific port coming from the pod is what you'll be able to access. You guys try it. Okay. Others tried it once. So if you look at the screen, now what happens in a cluster if you have a pod running? Okay, for example, let's take this pod 9. So when the pod is running, every pod will have a unique IP. So suppose, let's say, you are going to do some testing, then you will use this IP and you will be accessing the application which is running inside this pod and you will do some test. But what happens now? Let's say that you are doing some testing and for some reason this pod has been deleted. Okay. And suppose if you are running this pod using a deployment object or replica set object, then as soon as it gets deleted, the new pod will be replaced. So at that time, what will happen? Every pod will have a unique IP. Okay. Now this is where the first problem what we have is, how are you going to access a pod regardless of an IP? Because in real time, I cannot be dependent on this particular IP. Because if the pod gets deleted and the replica set or deployment object will recreate a pod, then a new IP will come. So every time when you create a new IP, you cannot expect the user to be aware of this IP. Okay, so which is one problem. The second problem is, This IP will work only within the cluster. So when I say within the cluster, if you go to the master or any of the workers in the cluster, it will work. If you try to use this IP outside the cluster, it won't work. So that's where, whether you are doing testing or production, you will not always go to the production machine and then use this IP. So you will be trying to access the application or the IP of the pod outside the cluster. So that's when the communication outside the cluster or the communication that has to be independent of the POID IP is what we need. Okay, so how do you resolve that? So this is where in Kubernetes, there is a new object called as service. Okay, so which exactly solves the problem on two things. One is we don't have to worry about the IP of the pod getting changed every time it recreates, or if you want to access the IP of the pod outside the cluster. Now for this, what we will do is we will create a new object called service object, and this we will apply to a pod of our choice. So what will happen is, now like I was saying, let's say you have an object created like replica set, and that will create a pod, and this pod will have the unique IP. And now if a user wants to access, first thing he has to go inside the cluster, and then he needs to access this IP. However, this is where if this pod goes down and a new pod comes, the replica set will recreate. But every time a new pod comes, a new IP will be there, which is the problem statement one that we are trying to address. In this, now what we will do, the same object, we will try to put it inside one more object called service. And what is the service going to do? So for every service object you create, it gives you a new unique IP, which is called as VIP. VIP stands for virtual IP. Okay. So for every service object you create, it will create a new virtual IP, and that you can apply on top of any of the object that you want. So then what will happen now, if a pod is running, the service will be running on top of it. So eventually, whatever the VIP or the IP that the service is given will be running on this. So now, as a user, you don't have to worry about accessing the IP of the pod. Instead, you can just refer to the IP of the service. So within the cluster, anywhere, if you refer to the IP of the service, then that will internally redirect to the pod, whatever is running in it. Now, the benefit is, for any reason, if the pod goes down, this replica set will create a new pod. But you can see on the same pod, the service will still be running on top of it. So that way, the IP of the pod will not change regardless of how many new pods are getting created. So that way, as a user, you can always access the VIP. So this is how, from now onwards, when you have a container running and you want to access the port of it, so the first thing that you have to do is you need to create one more object called service on top of it and use this IP, so that this service IP will redirect your traffic to the exact pod running. So that way, a pod getting recreated and a new IP of the pod doesn't matter to us. So we will be able to always access the application or whatever the pod that is currently available. Okay, so this is how service makes sure that it runs on top of your pod or other objects, so that the IP of the pod will be unique. But remember, you can access the service within the cluster. Okay, and the IP that whatever the service object is going to create will be by default a virtual IP. So it is not associated to any network interface. It's only for pure communication. Okay, but when we say service, there are different types of service, because whether you want to communicate within the cluster, or you want to communicate only to a machine, or you want to communicate outside the cluster. So depending on that, there are basically 4 types of services. Okay, so let's try to see one by one on how does it work. Okay, but when I say service, what should come to your mind is, instead of you accessing the pod directly, you will create an object called service on top of this, which will give a unique IP. And every time you access the service unique IP, that will redirect to the pod and wherever it is running. Okay. Now, out of this, the first type is what we call it as cluster IP. Now, what do you mean by cluster IP? Suppose you have a pod in which there is a container which exposes some port. Now, you want to access this pod within the cluster from any machine, but regardless of the IP of the pod. Then you can create a service on top of it. And if you make it as cluster IP, then the IP which the service gives will be available only within the cluster. Okay. So you can go to any machine in the cluster and you access this particular IP given by the service of the type cluster IP, you can access it within the cluster. Okay. Now this is where, to create a new object called service, you need to again define a new type wherein you will say kind is service, and then the API version, metadata, all those things will be there. But in the spec, you're going to tell what is the port that is coming from the container and what is the port that you want to access from the service. So that is what you're going to mark. And then you're going to tell the type of the service as cluster IP. Suppose if you do not give this also, the default value for the service will be cluster IP. But now the question comes is, how does a service know what is the pod to which the traffic should be redirected? So that's where, you recall, for every pod or a deployment object, we will give a label, right? So that label is what exactly you are going to give it as a selector. So first, you need to create a pod, whether you directly create a pod or using a deployment object or a replication object, you create, that is secondary. But for all the pods, what is the label that you have used? The same label you will use to service. So this is how, when you create a service, service will give you a IP. So when you access that IP, it will go to all those pods which has the same selector of the label, and it selects and it will be redirecting the traffic to those pod which is matching this label. So once again, your label is very important. Okay. So let's try that. So first what we will do, I'll create the service. So this is the service which we will create. And now you can see that I have the pod still running, doesn't matter, but I'll just create now a file called svc.yaml, and it's of the type cluster IP. So if you say kube13, it will create a new object called service or svc. If you want to see that, you can just say kube13 get svc, and it show you the details. Now you can ignore this Kubernetes, which is default. Now you can see we created a new service of the type cluster IP, and it has given a unique IP. And now there's nothing running. So if I just say curl of this IP colon 80, it will give an error, because right now, whatever the objects that we have, I have a label called my value demo, and there is no pod matching this, right? So when I go back to do a get pods. Labels. You should see there is nothing running. So what we need is, we need to create a pod which has this label. So what I'll do for this, simply will apply label. Okay, so kubectl label, apply this on a pod, and here we will say the pod name, which is nothing but just pod name. We'll keep what is the label. So I'll say label name equal to that. I'm just applying the label there. Now if you go back, you can see there is one pod which has this label. Now this is the label what the service is also referring. And now let me just clear this screen. If I access the pod, you can see now this is your service width, and this service width is going to internally refer to the pod. Okay. Now, regardless of this pod getting recreated and the IP changing, every time you access the service width within the cluster, you will be able to access this pod. So that's how, instead of worrying about the changing IP of the pod, you can use this service and you can access it. Okay. Now, let me share this quickly. Try to create on top of that pod what we are running on test 9 and try seeing this. Yeah, try running this and see. Okay, others are completed. Failed to connect. Can you share your screen? What have you done? Have you created a label on the pod?
Yes, yes, sir.
Okay, then it should be working. Can you? Okay, are you able to access the pod directly? Now, which pod is running? Can you show me that? Yeah, there's no label applied, right? Can you do a show label?
Sorry.
Kubectl get pods show label. Hyphen show labels. Yeah, show hyphen labels. Okay, so you have test pod 9. Can you access the test pod 9 directly? Curl 172, yeah. No, it's not running. That's what. Check what is there in pod 9. How did you create pod 9?
Sorry.
Okay, can you check how you created pod 9? So make sure the pod is first
Okay.
directly running, then you can use service on top of it.
Okay. Okay.
Others, did you try? Others, have you tried? Okay. I hope you guys have tried it once. Balaji, are you able to run?
No, I didn't. Same thing. It come. It came.
Now, can you show me what is the YAML file you have used for creating pod 8? Sorry, pod 9.
Yeah.
Okay, just everything looks fine. All right, just go to the pod now. Kubectl get pods.
Yeah.
So is it running there? Okay, so can you do a kubectl logs of pod 9 and see whether actually Apache is running inside the container? Logs-f test pod 9. Okay, looks like, what about this pod 8? What do you have in that? Looks like some problem. Can you delete the container and recreate it?
Yeah. Okay.
I mean the pod. Meantime, delete all the other pods. Maybe something else from that is causing problem. Just stop all the pods. Kubectl delete pod test pod 9 or test pod delete, yeah, pod test pod. And now you create that pod 9. Okay, kubectl logs. of this pod now and check whether you are able to access port 80 from this. You put the logs of that pod. Okay, looks like some problem. Can you do one thing? Are you able to run Apache? Now, just leave this. What did you have in pod 8? Can you open the pod 8 YAML?
Yeah.
Yeah, can you try accessing now? Pod 8. So what is that you are running? Apache in this or Nginx? In pod 8.
I will open that.
Okay, Nginx is running fine. Now try accessing this pod IP directly. No root to host. Can you do a sudo and then try? Yeah, some reason your port is not accessible for that user. That's a problem. Can you go inside the pod?
Yeah.
Just pod 8 or no, just don't give 00. Just say kubectl exe test pod. Yeah, remove that and see 00. No, exe -it. Yeah, remove that -c c00.
Yeah.
Try running curl here. Yeah, curl localhost. No, just say curl localhost. Yeah, colon 80. Yeah, it's working here. Looks like in your machine, probably that proxy server is not running. You need to check.
Okay.
Yeah, try to restart and see whether Minikube started, because you remember while I was explaining the components of Worker, there is a component called as proxy server. So we need to check whether
Okay.
that is running or not, because what's happening inside the container port is accessible, but your Kubernetes cluster is not able to expose them. So we need to see that.
Okay.
Okay, others, have you tried? Others? Okay, I think I'm not getting any update. Yeah, take a break, guys. Take a 10 minutes break. I'll talk to you again at 10:45. If you have not completed, just let me know. We'll come back and see. All right. Yeah, talk to you in 10 minutes. Take a break. Is everyone back? Okay. So I hope everyone tried the previous example. So the first type of service what we saw is cluster IP. That is, if you want to access the IP or the VIP which service gives within a cluster, okay, then you are going to create as a type called cluster IP. Now this is where we have a second type called as node port. So what do you mean by node port? Now,
please share your screen.
yeah. The screen visible now?
Yes, sir.
Yes.
So what happens now in real time? You are not going to always connect to a cluster, go to a machine and access the web, because anytime your application should be accessible outside the cluster. So this is where if you want to access the pod or the service with outside the cluster, then there are two ways you can do. One is if you have a single pod, then you can use something called as node port. Suppose if you have more than one pod and if you want to set up a load balancer, then externally, if you have a load balancer, then you can attach that load balancer to the service so that every time you access your pod or the service IP, internally it will be redirecting the traffic to the particular pod. So in that way, I don't think you might have a load balancer, but let's just see node port. So the scenario here is if you want to access the pod or the service IP outside your cluster, then what you will do when you create. Okay, so when you create the service IP, what you can do is you can specify it as node port. Then when you create the service as a type called node port, what Kubernetes will do is it will associate the VIP, whatever is coming from the service, to a cluster level. And for that, what you can do is when the type of the service is node port, in order to access this from outside the cluster, you can directly go to any of the worker IP, and in the worker IP, if you just access a port which the service, that is the node port, exposes, you will be able to directly access. So this way here, what does this node port does is, it takes the service web and attaches to the cluster. And for every cluster that it attaches, it gives a unique port of its own. So what you have to do is, if you access any worker IP colon the port what service has given, this will redirect to the VIP and VIP will redirect to the pod on which it is running. So this is how, if you want to access your service outside the cluster, then make it as a type node port. Okay. So now watch this. So current in my machine, I have this pod running and I have a service also. So if I access this, I can access it within my cluster, but to access it outside the cluster, it's not possible. So that's where what you can do, you can just edit the type of the service. So here, remove this and make it node port. Okay, where you need to make sure the N and P are caps, and just go ahead and apply the same thing again instead of recreating. I'm going to apply the same, and you can see it got configured. And now if you do a kubectl get svc, the type will be node port. Now you can access it within the cluster like usual. Okay, this will work. But if you want to access outside your cluster, then what you can do, you can go to the IP of this machine, and if you try to access this port, that is 32178, which is given by the Kubernetes service, then the 32178 will redirect to the VIP, and this VIP will redirect to the pods 80. Okay, so now if I want to access it outside the cluster, if you see here, let me come back. Now this is my machine. So let me take the IP. So here, if I say 32718, 32178, you should be able to access. Suppose if it is blocking, then make sure that you are allowing the traffic. So in my case, what I'll do, since I'm using AWS, so in AWS, so security group is the firewall where I can allow the type of port. So what I'm going to do now, here on the existing default security group, so I'll allow the port. Will be exposing the port in a range of 30,000 to 32,767. So whatever the value that you're getting from node port will be anywhere within this. So I will try to allow all of them. Okay, so now if I go to my machine and try to access, you can see I'm able to access that pod internally, which has the Apache. So what is happening? So I am accessing my host machine using a port which the service has been given of the type node port. And internally, here, if you see, this port will be redirected to the unique VIP of the service, and the service will redirect that to the pod which is running. So this is how, if you want to access your pod IP outside the cluster using the service, then you have to create the service of the type node port. Okay, so just go back, and all you have to do is change the same service, whatever you are running, to the type node port, and just do a kubectl get svc and see what is the port which the node port object is trying to give you. And from this, you come to your host machine and try to access it using the port, and it should be accessing the pod or the service web outside your cluster. Okay, so that's why cluster IP is for accessing within the cluster, and node port is for accessing outside the cluster. Can you try this? Let's try. Okay, everyone tried? Do you want me to wait for some more time, or have you guys tried it? Hey, what about others? Are you able to run, or guys, it's actually difficult. I'm really sorry to say this again. I'm not able to know whether you're completed or you're having some issue. We still have a lot of topics to cover. It will be easy at least if we can tell whether you have completed or is there any issue, or can we just move forward. Okay, I'm going to consider this you guys have practiced because I'm not getting any answers. So hopefully you guys might have tried. So let me just move ahead. Now there are two more types of services. I'll talk about that probably tomorrow when we go to different types of object, right? So in that way, load balancer is something we will not be able to do. But what we will do is there's one more called as headless service. So that I'll talk about when we go through a new type of object called as stateful set. Okay. But for now, what do you mean by service is there will be two scenarios where if a pod is accessed directly, then the pod, when it's get deleted, the IP will change, which is one problem. And the other problem is if you want to access it outside the cluster, then again, you cannot access it directly. So that's where you're going to use the service wherein you can access it within the cluster using cluster IP or outside the cluster using node port. Those are the two things what we have seen. Now, similar to port mapping, if you go back to Docker, so we have something called as volume mapping, right? So recall that. So the necessity of a volume mapping is when you have a folder inside a container, and if you want to access it from the host machine or in simple outside the container, if you want to access, then we saw something called as volume mapping. And in the volume mapping, what we did is we took a folder from a container and we mapped that to the host machine. So that if you go to the host machine, you will be able to access that folder. But what happens the same way now, if you try to take Kubernetes, you are not going to just map the folder from the container to the host machine, because in Kubernetes, you will never know on which machine the pod is going to get assigned. And that way, if you are having a pod created on some machine, then every time if you want to access, you have to go to that particular machine and access, which is one way. Now, other way is similar to how you had service in volumes also. If you want, you can map a folder coming from a container, which is the volume, which can be mounted on a single host machine or as a cluster. If you want to access this folder outside the host machine, that is outside the cluster if you want to access. So that is where there are different types of volumes. But the basic here is anytime if you are sharing or exposing a folder from a container, by default, it will be available only within the pod. It will never be available outside the pod. Same way like the port. Whatever the container is exposing, whether it's a port or it's a folder, it will be available only within the pod. So let's look at the first type of volume in Kubernetes, which is what we call it as MTDAR. Now, similar to how you had cluster, if you go back to the container to container communication within the same pod using localhost. Same way, now assume in your cluster, you have a pod and you have two containers inside the same pod. And if you want to access the container one from another container, or if you want to share a folder from one container to another container, then you are going to use a volume of the type MTDAR. Because in Kubernetes, a volume is not just container level, it is a pod level. So all the containers share the same volume. So if you create a pod with a volume of the type MTDAR, then what will happen? The containers within the pod can share among them, so that in the same pod, if you put something in one container, that will go to the volume, and from the volume, it will be accessible to another container. But this is within the pod. It will not be available outside the pod. And for any reason, if the container gets deleted and recreated, from the volume, you will get back the same content inside the container. But if the pod itself gets deleted, the volume will also get deleted. So that's where for every new pod, you will get an empty volume. And then when you start sharing between the containers, whatever the container gets created will go into the volume and shared across other container in the same pod. So such a type of volume is what we call it as MTDAR. So you're going to use MTDAR when you want to share something between containers inside the same pod. Okay. Now, to understand this, let's take an example. Now, to know this example, what we will do. So if you look at this example, so I'm trying to have two containers, container one and container two. So this is where, unlike your container in Docker, volume is not specific to container. Volume is pod level. So that's where, similar to how you have a parent key called container, you can see there is one more keyword called volume. So this means, like how you see in the diagram here, you are creating a volume for the entire pod, and all the containers will share. So that way, we are telling that the pod is going to have a volume. So the name you can give anything, but what's important is the type. So here, when you say MTDAR, we are seeing it that for this pod, whatever we are going to create, it is going to create a volume of the type MTDAR. Okay. Now, how do you access this within the container? So this is where in Docker, what did you do? You used to say Docker run -b, some host directory and then container directory, right? So that way, whatever the container directory that you have given in the Docker directly, that is what you are going to give per container. So what is that coming from this container as a folder, which will go to this volume, and that we will be accessing it on other container. Okay, because in this, we are not going to access this volume outside the container. We are trying to see how you can access a volume between containers in the same pod. Okay, so that way, under the container, you're going to use a new keyword called volume mount, which is nothing but this. Okay. And in this, you're trying to tell what is that volume that you want to mount. So the name that will be here should match the name here, and then the folder. So on the first container, what I'm doing is an example where I'm just trying to run a sleep command for 10,000 seconds. Now in this, there will be a folder called temp exchange created on the first container. Same way, if you come down on the second container, I'm using the same mount but to a different folder. Okay. So what does it mean? So this means the volume will be accessible in first container under temp exchange, and on the second container it will be accessible through temp data. So anything I store here will go to this, and anything I store here will go here. So that is how, as long as the pod is available, the folder will be shared between the containers. So this is where for this pod you are creating a volume, and within the container you are telling which folder should be mounted or mapped. Okay, so watch this now. So I'll just make it as empty. And so you should see two containers. Okay, now both the containers are up and running. So what I'll do now, I'll try to go inside the first container, exe, and the name of my pod. And now here I'll go to the first container. So the name of the container is C1, and that is temp exchange folder. Okay, so watch this. So under C1, if I just run this command, it is empty. Same way, we will go to second container. Run this, it's going to be empty. Now I will create a file inside this. Okay. So what I've done, you can see I've created a new file under second container in the folder called temp data. Now through the volume, this will be shared to the first container. So now if I go to the first container and ls the temp exchange, you should see the same file is also available. Same way, if I create a file again in this, so on the first container under temp exchange, it's available, but through the volume, it has been mounted on the second container also. So if I go to the second container, you should also see the same container. Okay. So this is how you can try to share files and contents between two containers in the same pod. For that, you are going to use the volume of the type entity layer. Okay. Let's try. Yeah, so I've just saved to this file. So can you quickly try and see how you can share between two containers in the same pod? Okay, others, have you tried? Okay. So the first one, what we saw is, if you want to share between two containers in the same pod, then you are going to use the volume of the type mtdir. Okay. Now, let's talk about the other type, wherein similar to how we had Docker, we now know if you want to map the volume coming from a container or a pod to a host machine, then by default, the machine in which the pod is running is what you are going to see this particular folder being mounted. So this way, in Kubernetes, there is a volume of the type called host path. So when you create the volume of the type host path, then what will happen? While you are mounting it, when you give a folder on the machine in which the pod is assigned and it is created, so on that machine, that folder will be available. Suppose in a cluster you have multiple machine. Now, in order for you to access this folder, so you should go to that exact machine in which you are creating the pod. Okay, so host path means you can share the volume from the pod to a host machine in which it is running. So it is going to typically run on the file system of the host machine. So anything that you share inside the container will be accessible to the host machine. And the same way, anything that you put on the host machine in this shared folder, it will be accessible within the container. Okay. Now, for this, what you have to do, so once again, you have to give the type of the volume as host path, and then you're going to give a folder name to it. So this is the folder which will be shared on the host machine. And when you go to the container, the volume mount you're going to give and then same name of the volume, so that whatever you put into this folder in the container will be accessible or shared to the host machine on this folder. And the same way, it's vice versa. Anything that you put inside this folder on host machine will be accessible inside the container. Okay, so that's where host path will help you to share between the container and the host machine. But remember, this will be mounted on the host machine in which the pod is assigned and container is running. So in a cluster, you should exactly first find out where is your pod running and you should go to it. Okay, now let me just show you this example. Okay, so here I'm creating a volume of the type host path, and on the host machine, you should see a temp data folder, and inside the container, it will create a new folder called temp host path, and it will share. Let's try creating this. Now on the host machine, now since this is Minikube, whatever you run will be created in the same machine, right? So here, if you see, on the host machine, there is no folder. Let's create called host path. To create a container. So now, once the container is running, so now if you see the host machine, so you should see the folder is created, but it is empty. Same way, if you go to the container and here I'll just say ls temp/host path. So it is also empty. So now if I create some file on the host machine under temp data, I'll just create it as host file. Okay. So now this is under host machine on your file system. Now the same thing, if I go inside your container, you can see that the same file is available. Same way, if I create container, you can see within the container whatever you have, same thing will be. Same thing on the host machine will be shared to temp data. Okay, so as long as the pod is running, you will be able to access this live. But for any chance if the pod gets deleted, then we know the basics from the Docker that the volume mount will leave a copy on the host machine. But again, so you should know on which machine it has been created. So you should go to that machine and access the shared folder. Okay. So let me show you. Here, if you go back and do a ls, you can see there is a copy which is being left. So this is how, by creating a volume of the type host path, a copy of the container's volume will be mapped to a host machine's file system. So that you have to. So try this. Let me just check this file in. Yeah, go ahead, create this and try to see how on the host machine it is sharing, and try to create a file on host machine that should be available inside container. Same way, anything you can create inside the container in this folder should be accessible from the host machine. And once you delete the pod, a copy of that will be left on the machine in which the pod was running. Okay, try this. Okay, you guys tried? Okay, others. Can you share your screen on what is the error? So first, can you check, are you able to create a folder directly called temp data as the user that you're running the kubectl command? Check that. And meantime, can you cross-check whether your container has been actually created or is there any error? Ashwini or Balaji?
Okay.
Can you open the YAML file what you have taken? Okay. Save and come out. Is the container running fine?
Sorry?
Is the container running?
Yeah, it's running here.
Can you do a kubectl logs of that? Nothing is there. Okay, something wrong with your Kubernetes setup.
Yeah, okay.
Can you create a folder directly? Temp data?
Yeah.
Just create a folder called data.
Yeah, I created it.
Okay, so can you delete the pod and create it again? You recreate the pod and then show. Yeah. And now
I created.
yeah, can you just create a file inside container and see whether it is sharing on the host machine? Yeah, go inside the container and then create a file under temp host path.
Sorry.
Okay, yeah, create a file inside it now under temp host path. Yeah, check on the host machine. Okay, looks like there's some problem with your host machine and the container, or sorry, the cluster is not created because volume mapping, same problem, even
Yeah, okay.
if not sharing. Is everyone
Okay.
getting the issue?
Yeah, okay. Thanks.
Okay, I'll suggest one thing because anyway, its time is not there. So go ahead and restart Minikube once and then try this and check and let me know if it is working tomorrow. We'll
Yeah,
continue with that.
yeah, okay.
Okay. Yeah, because it's not a issue from the Kubernetes, but looks like the machine is not running cluster properly. Okay, sure. Anyway,
Yeah,
you
yeah,
guys
thank
just
you.
try to restart and let me know whether it's working or not in the morning, and then we'll try to continue. Okay. Okay, sure. If that's the case, then I'll stop today. Tomorrow, let's continue with this, but just make sure you try it once we're restarting and let me know. All right. All right. Sure, guys. Then I'll talk to you tomorrow. Have a good day.
Thanks, sir.
Hey, thank you.